If it's going. Yay, we're live. Okay. So what do we say? 7H or 7? Let's do 7. 7G is a lot easier than 7H because the Sparker sucks. I just got some news. Lillian, I was thinking about your refillable juice box idea. Yeah. Refillable expo markers. That'd be pretty cool. You do?
Juice boxes are way too small.
They're very difficult to find, but I'm almost 100% positive they
But what?
refillable dry rates, not expos.
How is that 100?
5 of these a day and I love it.
How many calories are in that tiny little box?
35.
Oh, okay. Sometimes those little ones have like 100 calories, and I'm like,
No, I also get chocolate bars. Calories? I literally have never listened to what calories.
You're looking for more calories or less calories? Well, you're a runner. Usually, a lot of times when you're doing like endurance sports. Oh my God. But I'm saying a lot of times when you're doing endurance sports, you want maximal calories for the smallest volume. Like Stinger, these little Stinger gummies are like the most amazing thing. You get like 200 calories with like just a little bit of, and you eat them so easily.
Yeah, I don't really ever pay attention to
one time I tried the Angry gummies during like a long race,
Yeah.
and it didn't go very well. I had to pull over on the trail a few times.
Yeah, the Haribo gummy bears. Yeah, there's all these nightmare stories about them. Like people who like people who eat like a whole bag of those on a flight and then they have to go. Okay, so anyway.
It happens to the best of us.
Yeah, happens to the best. So this problem here, I don't know, do you guys see how, I mean, it's clearly a thing times a thing, right?
Yeah.
So is there any way to not see it that way? I don't think so. I mean, maybe technically expressing this as some power of 7 and then absorbing it in, but that's way more work than it needs to be. So this is an A times B. So remember when you have the product rule written down, hopefully. A times B, the derivative of that would be A prime B plus B prime A. So it's going to be, so the derivative, again, make sure you're familiar with all the different notations for saying the derivative of this function. So this is one way to write it. I could have also written f prime of t. That would have also worked. Those say the same thing. So anyway, so here's A, and here's B. Now here's the thing though. I'm gonna go, what's this gonna say is A prime, so A prime is pretty easy to do, right? 15t squared. So there's A prime times B, and B is just this whole thing, so t squared plus 1 to the 7. So there's A prime times B, but then you gotta go plus B prime times A. And I'm gonna leave a little gap here for now because you might go, wait a second, isn't that like a whole, that's like a whole problem in and of itself. Finding B prime, because you gotta use the chain rule to find B prime, right? So as you do more of these, it becomes easier and easier though. So anyway, let's put A in there. So A is just 5t cubed. But I have to make sure that I can put B prime here. So maybe in the margin you go, well, let's take the derivative. If I'm saying that B is this t squared plus 1 to the 7th, what would B prime be? Well, it's going to be
7t squared plus 1 to the 6th times 2t.
Does everyone understand that?
Yeah.
So in here, you have that. So 7 times t squared plus 1 to the 6th times 2t.
Actually, well, where did you get the 2t?
So I was thinking of this as u to the 7th. So then u to the 7th becomes 7u to the 6th times 2 prime.
Okay, yeah. Okay.
What?
Oh, no. I just, no.
Okay, so simplifying your answer is this guy can't be simplified. So 15t squared times t squared plus 1 to the 7th plus, this guy can definitely be simplified though, because I've got 7 times 2 times 5, which is 70, or 5 times 2 times 7 is probably easier way to think about it. 70t to the 4th power times, beans.
Yes.
So,
Yes, makes sense. Okay.
so there's no questions on that one? All right, so, well, we can look at H as well. H is kind of similar, but once you get the hang of like doing this kind of thing, and this next problem we're going to do is going to involve doing this. The square root of u ends up becoming 1/2 u to the negative 1/2 times u prime, which you could write as u prime over 2 root u. Does everyone understand that? Or so once you get familiar with that idea, it sort of speeds things up. It makes it a little bit more fluid.
And
So
you don't have to show that, if we understand that. Or-
no, you don't have to write the u's.
But you don't have to, like, we don't have to show the simplification, but we can just write b prime as what b prime is.
Yeah, like this.
Okay.
Yeah, like on this problem, you can go straight from this to this.
Great. That's all I.
You don't need to list out what A is, what B is. You certainly can. Like a lot of people, when they were first learning this, they insist on writing out. Here's what A is. Here's what B is. Here's what A prime is. Here's what B prime is, because it helps them keep things straight. So certainly don't hesitate to do that. Let's do 7H to make sure there's no confusion. So keeping in mind that what we just talked about, where square root of u, the derivative of square root of u is going to be u prime over 2 root u. We're sure there's no questions on that, right? Okay. Yes?
You're just doing, you're just multiplying the u prime back over, right? Because technically, the derivative of square root of u is just 1 over 2 u, right? So then you're just putting the other one back in.
Exactly. Yep. So this one, we're taking the derivative of x times the square root of this u. So again, you can figure out a way probably to absorb. I'm just trying to think, if you absorb this x in there, you should be able to do that without any sort of funny business. But again, let's just do the product rule. You guys see what I'm talking about? Like you could write this as square root of x squared, or can you? Because x is not the same as the square root of x squared. Yeah, you're gonna maybe run into some issues there. Oh, so in case you're, what are you talking about? I'm talking about, you could actually sort of kind of rewrite this as, if you rewrote this as square root of x squared and then you absorbed it in. The only problem with that is that this thing can be negative if x is negative, but this thing can't be negative. So you're running into some kind of issue for the left side of the function. Anyway, long story short.
Wrong.
Sad. Okay, A times B, right? A times B. So it's going to be A prime times B. Cool beans. A prime times B. Plus, let's use this fact now to get to B prime. So B prime is going to be 2x. All right, let's pause there. Does everyone understand how getting this B prime was utilizing this fact? So this says square root of u, right? So this is my B here. This is B. This goes A, This guy was b. So the square root, this says basically that b is the square root of u. So what we're doing here is to get this b prime, it's the derivative of this, that's what we were just talking about a few moments ago. So my b prime is going to be u prime over 2 root u. There's my u prime, right? I'm losing you guys, or does it make sense? Okay, so that being my u. So 2x over 2 root u. And then what am I missing there? So this again says a prime times b plus b prime times a. Let's simplify it. Don't need the 1 there. 1 times banana makes banana. 2 divided by 2 is 1. X times x is x squared. What is that? There we go. Now that's a nice derivative. Look at that. Yeah. Nice, concise form.
I must be the worst person ever.
You must be what?
The worst person ever, but.
I
I
think
just
you're
love
great,
it so
Jesse. I
much.
think you're great. So you'll notice that on like 8, quite a few of those involve, actually, I think all of them involve to some extent a combination of, there's like a little mini chain rule embedded inside a product rule or quotient rule. So let's maybe do one or two more examples just for the video, so you guys have something to work off of, and then we'll have take the rest of the class to work through some more problems. We'll do one example where you're plugging in, but that's fairly straightforward, hopefully. Let's do, here's one that involves a quotient rule. We can do that. How about, let's look at 8a. Kind of pepper them around here, I guess. Eight A. Alright. So again, do you guys see how, do you see how you could do the product rule or the quotient rule here? Like if you rewrote this as this thing, this 4x plus 1 cubed times x to the negative 2, you could certainly use the product rule. But let's use the quotient rule. So you got, here's your A, here's your B. Do you guys see how getting the A prime is going to require a chain rule? It's like a u cubed. So keep in mind for getting that whenever if you have a u cubed, that's going to turn into 3u squared times u prime. So we're going to utilize that fact when we're getting the A prime. Okay, so this is the A, this is the B. So the derivative, y prime, A prime. So let's get A prime. So the A prime B minus B prime A all over B squared. So a lot of times we like to just put in the easy stuff first. So like what are some easy things here that we can put in with our quotient rule formula? Certainly the B squared is easy, right? You just have to do that. Right? And then the B prime A is pretty easy. So I hope you'd agree with that. Because B prime A would just be 2x times that thing we're calling A. There we go. So it's going to say A prime B minus B prime A all over B squared. So A prime is going to be, stop me if I lose you here, 3u squared times u prime. Now that's just a prime. So a prime times b, I gotta squeeze an x squared in there. Sorry, it's kind of cramped, but. Let's simplify this. So you got 3 times 4 times x squared. It's 12x squared. And here is just, we could get rid of an x, by the way. We start thinking ahead. Let's do that. Might as well, right? We can think ahead. We have the power. Because this is going to have, we're going to have an x to the 4th on bottom, an x squared on the left, and an x on the right. So let's divide everything by x to actually have 12x. And this will just be a 2 times 4x plus 1 cubed. And then on bottom, since I divided both top and bottom by x, I'll just have x cubed, not x to the 4th. Yes. Yes, indeed. So there you go. If anyone's feeling confused, I can talk to you about it individually while we're working in class here, but hopefully it all makes sense and you're able to kind of tackle the questions. So, all right. Oh, I said I was going to go over one with a number. Sorry. I guess, yeah, that's my bad. We'll do that. So you'll notice that on 9, on 9, you're basically taking the derivative and then evaluating. And on 10 is asking all about second derivatives. But you guys, I mean, those can sometimes be a little bit of a pain if they're involving like a product rule, because as you can see, these things kind of expand and get bigger when you take their derivative. So take the second derivative will a lot of times be a little annoying. But that's the thing, the key about those is to make sure you simplify the first derivative before you take the second derivative. Simplify it as much as you can, and that'll save you some time. Let's do one. Okay, let's just do one of those. On number 9, you literally just have to plug in the number at the end. Take the derivative, plug in the number. So they shouldn't be too taxing. But let's do a second derivative. That'll make more sense, I think. Yeah. So we'll just do 10a, I guess. That'll be our last one today. Do it together. Okie dokie. What do you guys think? Should we do a chain rule or should we do a quotient rule? Quotient? Sure. Quotient. Quotient's nice if the top's a constant. You'll hopefully that you see why that is. If not, you're about to. So let's say I call this thing y. Well, okay. Y prime is going to be, so here's my A, here's my B. So do you guys see what's going to happen with my first term? What's A prime? 0. So it's 0 times 2t plus 1, right? A prime B minus B prime is 2 times A. So the top's just going to be a constant, which is nice. And the bottom is going to be 2t plus 1 squared. Now, this is what I was talking about a second ago. Make sure you simplify before you go for your second derivative, because this is obviously much simpler to look at. Like that. Okay, that's the first derivative. Let's go second derivative. So reset your A and your B. There's my A, there's my B. So what's B prime going to require us to use? Chain rule, exactly. Okay, so once again, A prime times B minus, this is going to be a little bit of a pain, but there's where I'm putting my B prime times A all over B squared. We feel okay about that? So A prime B minus B prime A all over B squared. So okay, we gotta do B prime now. So that's gonna be 2 times 2t plus 1 to the first power times 2.
Oh, wow.
Okay, happens. Sure there's no questions on that? Yes. This?
Yeah.
Okay, so let's make sure we're on the same page then. This is A, this is B. So you're cool with how that's A prime and that's B. So getting B prime basically is like saying, well, I've got U squared. So what's the derivative of U squared? 2U times U prime. And so what this says is, I'm calling the U is this 2t plus 1 in here. That's the U. So this reads 2U U prime. Everyone okay with that? Okay. Y double prime equals, all right, look at this. 0 times this would make 0. So this is just nothing. Over here, let's be really careful here. So you got -2 times 2 times -6. What does that make? 20. On the bottom, something squared is to the 4. Now we can do one more simplification here. We have 1 banana on top and 4 bananas on bottom. So one pair of those cancels out. We get this really nice, elegant form, which I find very aesthetically pleasing. There we go. So it turns out, after all that, the second derivative is, look how similar it is to the original function. It's kind of neat. So the third derivative would be, again, pretty similar to this, but we have a 4th power, and then a 5th power, and a 6th power, and a 7th power, and so on and so forth. So you can see a definite pattern emerging as you take the derivatives. Okay, dokie. Oh, Kate. She sent gifted subs. Thanks for the gift. Thanks for the 100 bits, Kate. Choose NB. Unfortunately, it doesn't like. Oh, sorry. Oh, she's right there. Hello. She wants to come say hi. Let me email you in a second. I can answer your question. Kate said hi. Okay, I'm ending the stream. Kate, I'll email you.